Hello guys, so today I'll be solving this problem, which is maximum product of splitting a splitted binary tree. So the question says that we have been given a binary tree and we have to split the binary tree into two subtrees by removing only one edge, such that the product of the sums of the subtree is maximized. Okay, and yeah, whatever the product is, we have to take the modulus using of this value. Then yeah, our goal is to maximize it. So yeah, so this note thing is important because it says that you need to maximize the answer before taking the mod, not after taking mod, which means like when we are updating our variables. Okay, so we don't need to take the modulus at that point. After we have gotten the final answer, then only we have to take the modulus. Okay, so yeah, cool. So what the question is saying is, so let's say I have a tree something like this. Okay, so let's say I extend this to something like this. Okay, let's say I cut this part. Okay, so now this tree will look like something like this. Okay, now here's the thing is, what we have to do is, whenever we are cutting off an edge, okay, we have to take the sum of nodes in this subtree and the sum of node in this subtree. Okay, and let's call it sum1 here, and let's call it sum2 here. Okay, now the value for this cut will be sum1 times sum2. Okay, this is the value of this cut, and we need to find which cut produces the maximum product. So that's the question. So for example, let's take this one. Cool. So what happened here is, um, so here in this test case, they cut off this edge. Okay, now when they cut off this edge, the sum of the nodes in this subtree, which is this, was 6, and the sum of the nodes in this subtree was 15. Okay, now if I look at the product of this, it's 90, which is the maximum value that I will get considering all the cuts that I can do. So how to solve this problem? So it's a basic tree traversal problem, which means like it's a basic DFS slash BFS problem. Okay, so the code will be much simpler with a DFS approach. BFS you can also go through, but yeah, it's much simpler in DFS. So what we need to do is, so what we are doing, so whenever we are cutting off an edge, okay, so whatever subtree we are getting, okay, that sum we are considering. Okay, and we need to consider the sum of the other part. Okay, now what will be the sum of the other part? Okay, so let's say if I know the sum of all the nodes in the tree. Okay, for example here, if I consider the sum of all the nodes, node I value. Okay, this will give me the total, right? Now whenever I'm cutting off this subtree, okay, how so I can use this total to efficiently find the sum of this subtree. How? So let's say I'm at this peak. Okay, then um, if I know the sum of this subtree, okay, let's call it some sum of subtree. Okay, now for this subtree, whatever linkage it has with this parent. Okay, so from parent to all over, like all the nodes above parent also. Okay, that sum will be total minus sum of subtree. Cool. So this will be my sum1 and this will be my sum2, and it's quite intuitive, right? Because if you know the sum of the nodes in a subtree, okay, to calculate the rest of the sum, okay, or the rest of the nodes sum value, okay, that will be simply whatever total nodes sum you have minus the current subtree value. So that's the idea. So what we will be doing is, uh, we will be iterating over all the nodes. Okay, we'll be calculating the sum of nodes value for like sum of nodes for every node. Okay, then from that we will first find the total value. Okay, then we can store all the sums for each node, okay, in a list maybe. Okay, this will store the sum of nodes, okay, considering node I as root node of the subtree. Subtree. So if we have the sum, okay, then we can easily iterate over them. Okay, now every sum in this list will act as a sum1. Okay, okay, then in order to find the sum2, okay, we'll be simply doing total minus sum1. Okay, and let's say we have a global answer variable, so we will be maximize our answer variable with max of ans sum1 times sum2. Sum2 will be this variable. Cool. Now during all this processing, okay, we will not consider mod. Okay, only when our answer has been updated to its final maximized value, then only we will return answer mod. Okay, so here mod will be this 10 to the power 9 plus 7. Cool. Now it will better for me to show you how you can calculate the sum1 value for every node. Okay, it's a basic DFS approach, just iterate over its left and right child. Okay, now in you can do a pre-order traversal. Now after doing the pre-order traversal, you can get the sum of its left subtree for a node and get the sum of the right subtree of that node. Okay, then yeah, with that you will be able to get the sum of the node, okay, considering node I as the root. So yeah, I guess I'll show you, or maybe I can run a test case here. Okay, so what I will be doing is first I will run the DFS. Okay, so here there is 1 2, or let me cut off this image. Cool. So I'll be doing DFS. Okay, so initially I will start from here. Okay, now I will iterate over its children. Okay, I will point to here, then from here I'll go to here. Now after this I have nothing, like nothing, so no childrens are there. So what I will do is I will propagate the node value, okay, the sum of the nodes, considering this node as the root of this subtree, okay, to its parent. Okay, so I'll get a +3 to this node. Okay, then for this node, so I have iterated over this children, so I'll go to this node. Okay, now from this node I see children, so I'll again go to the left, so I'm doing a pre-order traversal. Okay, now from here also similarly, so no childrens are left. Okay, so I'll propagate the whatever sum I have gotten to the parent, so +5 here. Okay, then similarly for here, okay, I will propagate it to the right part. Okay, now for this node there are no children, which means the sum of all the nodes is 6 here, so I'll propagate 6 to it the parent. Okay, like that in my sum array it will look like. So first I populated 3. Okay, then from here I went to 2, then from 2 I went to 4, then from 4 I went to 5. Now in 5 I didn't find any children, so I propagate whatever the subtree sum value to the parent, which means I will add 5 here. Then similarly for this 6 node also, so I propagated the sum of the nodes of this subtree to the parent, which means I will add 6 here. Okay, so it's a simple DFS approach. Now when I'm at this, okay, I'm done with the children. Now I'll update the subtree sum value to 5 plus 4 plus 6, which is 15. Okay, then I'm done with all the children of 2. Okay, so I'll propagate 15 here. Okay, now considering this node as the root of this subtree, okay, I'll find the subtree sum, which is plus 3 plus 2 plus 15. Okay, this is 6 plus 15, so 21. Okay, then yeah, sorry, 20. Then from here I will traverse, like I will push the sum of this subtree to the parent, which is 1 here, so plus 20. Now for this node I'm done with all the children. Now the sum of the subtree, considering 1 as the root node, that will be 20 plus 1, 21. Cool. So this is how my sums array will look, which which stores the sum of the subtree of every node, considering the node as the root of itself, like root of the subtree. Cool. Now how can I use this is, so basically it gave me all the subtree sums. Now I will simply iterate over them, okay, and I will use this algorithm. Okay, so sum 2 I can easily get from the total. So from sums also I can get the total, which is like the maximum value. Total will be max of sums. Okay, then yeah, I'll just run this, and I'll calculate the product of the subtree and the sum of all the nodes above it. Okay, and with that I will be updating my answer. Cool. So that's the idea behind the problem. So it's a basic DFS, like a tree traversal question, so nothing beyond that. So yeah, I'll first code the solution in Rust, and then we will discuss about the time complexity. Cool. So first I will create a DFS function. So I'll say DFS node, and I will take an option because I will just take the definition of this node here. Okay, then I will have a sums array. So that will be a mutable pointer to a vec of i64. I'll just expand this to here, and it returns i64. Cool. Now I'll say if let sum, let's call it RC. Okay, node. Okay, so here I'm saying that if node is not nil, okay, if it has some value, okay, then take that pointer. Now using that pointer, get the do a borrow of that value. Okay, so this is specific to Rust. Okay, in C++ and let's say Golang or any other language, you don't need to do this borrowing. This is specific to Rust. So yeah, I borrow the node reference, then I will calculate the sum of the nodes in the left subtree, so which will be again DFS. I will pass n dot left, and I will pass this sum. Okay, cool. Now similarly I will pass I will do for the right subtree also. So for right, again I will pass sum. Then once I have gotten the value for left and right, okay, which is this part, like they have propagated their sums to this node value, then I will calculate this sum at this node value, which will be, let's call it S. So which will be the node value itself. I will typecast to i64 plus left plus right. Okay, then I will update my sums list, sums dot push S. Okay, then I will return S. Okay, now let's say the node is nil pointer. Let's say from here I propagated to this part, so here there is nothing, right? So this is basically nil. Okay, so no left and right children are there. Okay, so in that case I will simply return 0. Cool. Now with that I will touch over every node, and I will get the subtree sum value. Okay, then I will create this sums list. Okay, so I'll say it's a vector of i64 variables, and I'll call vec of new, so it will give me a vector of i64. Then I will create a variable of total. Okay, now since I am returning the sum of all the subtree, okay, which means for the root node also I will directly get the sum value. So I'll simply call DFS of root. Okay, so this will give me the total sum of the nodes. Okay, cool. So by that I don't need to do that, do this max call, okay, because DFS is already giving me. Cool. Then I will create my answer variable. So let mut ans 0 as I64. Then I will create my modulus value, so which is mod, uh, which is 10 to the power 9 plus 7. Okay, cool. Now I will simply iterate over all the sum. Let's call it sum uh, 1. Okay, in sums I'll take a reference of that. Okay, then or maybe I can do something like this. Okay, I'll iterate over all the sum. I will update my answer as max of, I need to use std comparator, std comp max. Cool. Now max of ans and sum times the sum of the nodes, the sum of the rest of the nodes, so which is total minus sum. Okay, the exact thing that we did here. Okay, I just substituted this value directly here. Okay, total minus sum 1. Cool. With that my answer will be populated, like updated to the maximum product value. Then finally when I'm returning my answer, now only I need to do the modulus, like as per this note. Okay, now after doing that it will give me the mod value, and then I need to typecast it to I32. So I'll say as I32. Now if I run for all test cases, I get an error. Cool. Because I have not annotated this part, so this is a I64 variable. Now let's run for all test cases. DFS of, oh, I didn't pass the mutable reference of sum. Sums. Cool. Now with that, now this is RC, which is also a reference here, so I need to return the like pass a reference of root. Cool. So initial test case passed. Now let's submit. And voila, we got accepted. Cool. So this is the Rust solution. Now if we look at the time complexity here, okay, so what we are doing, so let's go step by step. So we have a DFS loop which touches over all the nodes only once, right? Cool. So this total, okay, so in this line 38 we will be touching over all the nodes, so which is big O of all the nodes. Okay, now we have this sum loop, okay, which is iterating over all the sums that we got from each node. Okay, which means again the length of sums will be the number of nodes we have, so it will be big O of number of nodes. Oopsie. Whew. I didn't lost the data. Cool. All the nodes. So the overall time complexity will be big O of 2n, n being the number of nodes, which we can say a linear time complexity algorithm. Cool. Now as per space complexity, so we are using this sums array. So at max it will be storing the sum of all the nodes, considering them as the root node. So it will be big O of number of nodes, which is big O of n. Cool. So it's a linear time complexity, and it also has a linear space complexity. So yeah, this is the overall time and space complexity. Now the same code I can show you in C++. So the code is exactly same as Rust. Let's submit the Rust thing again. Okay, now if I show you the code side by side, so the same thing we are doing. Okay, so here instead of I64 I am using long, then I have this vector sums array, then I have this DFS loop, which is basically so it doesn't have this Rust kind of a syntax. Okay, so it's basically whenever the node is not a valid node, like it's a nil, just return 0, otherwise get the sum of the node at that level. Okay, then propagate to, like, move to the left subtree, okay, get the sum of the value, then move to the right subtree, get the sum of the right subtree nodes. Okay, then get the sum of that, then push it to sums. Okay, then find the total, and the same stuff that we are doing here, just iterate over each sum, get the sum of the current the current subtree sum times the sum of the rest of the nodes. Cool. Now this is the C++ code. Now if I run it for test cases, it passed. Now if I run it for all test cases, and voila, it got accepted. Cool. Now similar code I can show you for Golang also. So for Go also, so I just created this DFS definition. Okay, this will help me to use DFS function here. Okay, otherwise if I would have used something like this, okay, the compiler won't know DFS because DFS is getting its definition from here only. So first I define my DFS function definition here, then I can use this definition inside here. Cool. So yeah, here also I'm creating this sums array. Then in this DFS call, I guess it's pretty similar to the C++ code. If the root, if the node is not there, okay. So instead of root, I can say node here. That will be more intuitive. Cool. So yeah, this is the function. Takes the node. If the node is nil, return 0. Otherwise, get the sum of all the nodes from its left and right, added up to the node own value. Then you will get the sum of all the nodes, considering that node as the root value. Then yeah, once you are done that, just push it to your sums array. Then with that, you will get the total sum by calling the DFS over the root node. Then yeah, simply iterate over all the sums that you have gotten and get the product of that. Now if I directly submit this, I hope it will work. So yeah, it should work. And voila, it got accepted. Now all of this three code have the same time complexity and space complexity. Cool. So that's all for this video. So if you like the solution and the explanation, please do subscribe to the channel, and you can hit a like button in the video. And if you feel like somewhere I'm lacking in the explanation, or there is something like you didn't understand in the explanation, please do comment so that I can help you guys. So yeah, just stay tuned to watch more videos. Bye bye.